So before you start working with strings in C, there's a couple things that you have to be aware of. And the first and most important is that C does not have a dedicated string type. So you're never going to actually declare a string variable in C because there's no such thing. Now, by this point, you've probably seen many C programs that had strings in them. However, while C doesn't have a designated string type, you can represent strings in C using null-terminated character arrays, and we'll see an example of that in a moment. The null value in C is represented by the character \0 that has ASCII value 0 as well, but instead of actually putting an integer 0 in our array, we'll use this character form just in case we're on some sort of weird architecture that doesn't have a 0-based null character. Now, if we have a string literal, such as this, where we have C string, which is 7 characters enclosed in double quotes, that's called a string literal, and those all have an implicit null at the end. So this is actually 8 characters in C because you would have the CSTRING, that's 7 characters, and then there would be an implicit null at the end of that, giving you the 8th character. So here's an example of what happens in memory. Here I have a string literal, ABCDEF 1, 2, 3, and you can see that in memory I get ABCDEF 1, 2, 3, and then a null terminator because this is a string literal, so this is an implicit null. So this is a valid C string, so I can declare string variables. Again, they're not really string variables, they're character variables of some type, either an array or a pointer, but we can say that they're string variables because they're referring to a valid C string. In the case of an array, the memory allocated for this variable str will get filled with these values. So str would look just like this. In this case, this is a character pointer. For a character pointer, this string literal would typically be stored in static memory, and then you would get a pointer to that static memory. And just as a side note, a lot of C compilers will actually let you modify a string literal that's stored in static memory, although C++ will not. So here I have a character array initializer, but notice there's no null terminator. So that means that this is not a valid C string. So if I declare a variable like this is not a C string, this is just a character array. So here's an initializer, and notice there's several individual characters, but then there's a null character at the end, meaning that in memory we're going to have a valid C string here. So this is a valid C string. We can declare a variable like this and initialize it with this initializer. It'll be a valid C string because there's the 0 at the end. Now, another area of difficulty or confusion that sometimes crops up is the difference between the array and the string. And one thing to keep in mind is that all the characters in a valid C array may not actually be part of the string. So in this example, I declare a variable, and you see the value CSTRINGS with the null terminator at the end. Now, if I print this using putS in this case, I'll get the output C strings. However, if later on in my program, I go in and I set the character at index 3 to the null character, notice now I have a null character here. So when I print this string, you can see that it actually only prints the first 3 characters. It ignores these completely because when you're treating a character array like a string, it ends at the null terminator. Now there's a downside to this too, because if there's no null terminators in that array, then all of a sudden when you pass that to a string function, it's going to keep working on that string until it finds that null terminator, which could be later on in memory. And if you're doing anything that changes the string, you could in theory change other code. So that invokes undefined behavior, but typically you'll wind up overwriting code. So keep in mind that there is no bounds checking on arrays or strings because all strings are arrays in C.